Hello everyone, let's discuss the fourth problem of AtCoder beginner contest 347, which is pop count and XOR. So what is the problem? We are given three integers, non-negative integers a, b and c. Now we have to determine if there is a pair of non-negative integers x and y that satisfies all of the following five conditions. So the first two conditions are on the limit of x and y, that the x and y should belong to 0 to 2 to the power 60, and the third condition is that pop count of x is a, the fourth condition is pop count of y is b, and the fifth condition is that x or y is c. So what is pop count? Pop count means that if we represent a number in a binary format, the number of ones is the pop count. So let's say for 5, let's say 5 in 10, base 10 is nothing but 101 in base 2. Now the pop count of this will be 2 because it has two ones. Okay, now there are five conditions. The first two conditions are not yeah, it's important obviously, but the last three conditions are the main one. So this is kind of a constructive problem. We have to construct the solution. We have to find the value of x and y. There could be multiple possible answers, and if there is no answer, we have to print -1. And if there are multiple answers, we can print any of them. So let's take the first example only. A is 3, B is 4, and C is 7. So 3, 4, and 7. So first, let's represent our 7, the value of C, in the bitwise format. So it will be 1, 1, and 1. Now let's jump into the observations directly. Okay, so we can see that there are some zeros here, some zeros. What are the number of zeros? The number of zeros are 57, because the numbers there are 57 zeros, because we can have only 60 bit values, because a and b are less than equal to 60, and x and y are less than 2 to the power 60. Okay, there are 57 zeros here. Now here you can see that uh, the bits uh, now let's first discuss about what is a XOR operation. I know all of you know it, but still let's explain it. So let's say we have two integers 100 and another integer 101. Now what XOR does is that if there are two bits which are same, then that will be 0, and if the two bits are different, then that will be 1. So uh, our C value is 111. That means that these three ones will be set in each it could be set in either x, or it could be set in y. Okay, so what, let's consider the number of set bits in C as p. Okay, the number of set bits in C as p. Now total number of set bits we have in x and y. Let's consider total number of set bits in x and y, that is a plus b. Okay, now we have a plus b. Now from this a plus b, we have to take this p ones. Okay, so let's consider d as a plus b minus p. Okay, so after setting this, after setting all the bits in x, we have a plus b minus p number of ones left. Now all the other positions in C are 0. That means that these ones should be distributed over x and y equally. So what I am trying to say is that we have to have d by 2 ones in x, and we have to have d by 2 ones in y. That's the first observation. So these are multiple observations we are making, but that is one important observation, that there would be d by 2 ones in x, and there will be d by 2 ones in y. Now for that case, we have one candidate when our answer is not possible, when d is odd. So if d is odd, then our answer is not possible. This will be -1. That's the second observation. Now let's jump into more observations. Okay, now we have already set a plus b minus p number of ones equally in x and y. Okay, now there will be d by 2 once in x and d by 2 number once in y. Now what if d by 2 is greater than a, or d by 2 is greater than b? Okay, if d by 2 is greater than a, and d by 2 is greater than b, or we can merge these two conditions, or directly say that if d by 2 is minimum of a comma b, then we can't really set this d by 2 once in either x or y. So in that case, if d by 2 is greater than minimum of a comma b, then our answer will be also -1. So these are two cases when our answer will be -1. Okay, Now let's discuss the algorithm. What will you do? We'll find the number of bits, number of set bits in C. Let's call that P. Now we'll check that we will find D as the number of bits where total number of bits which is set in X and Y both. So there will be D by 2 bits which is set in X, and there will be D by 2 bits set in Y. Okay. Now what will you do? There will be a minus d by 2 a minus d by 2 once a minus d by 2 once in X, and b minus d by 2 uh, once in Y. Now we'll iterate over all the bits, all the 0 to 60 bits. We'll iterate over all the bits from 0 to 60 and check if the ith bit is set in C. We'll first try to make all the bits set in X, and after this a minus d by 2 bits are done, we'll check all the b minus d by 2 in Y. So let's jump into the code. You will understand it better. So what I am doing, I am checking, I am iterating over all the bits, all the 60 bits. If it is set in C, and I am checking that the count of the bit is less than a minus 2, a minus d, we are setting it in X. A answer is nothing but X, and B answer is nothing but Y. So if count is less than a minus d, we are setting it in X, and otherwise we are setting it in Y, and we are incrementing the counter. So first a minus d set bits of C will be in X, and the next a minus d bits will be in Y. Now this is for case where bits are not set in X. So if the bit is not set in C, the bit is not set in C, and this CTB is our this counter that we have to set d by 2 bits in both X and Y. So that is that count of B is less than D. Count of B is less than D. So d by 2 bits in X and d by 2 bits in Y. We are setting answer plus equals to 2 into 10 to the power 2 into 2 to the power I, and Y is equals to 2 into 2 to the power I. D is a plus b minus p by 2. Here I told that D is a plus b minus p. We will divide it by 2. So there will be d by 2 bits in X and d by 2 bits in Y. So our after that we will print our X and Y. So I coded this solution, and here the three cases that a plus b minus p, if it is less than 0, our answer is not possible. If it is odd, then our answer is d is odd, then our answer is not possible. And if it is d is greater than minimum of a comma b, our answer is not possible. But there is one case which I have missed. I will explain this case to you. That is one edge case I had missed and have multiple wrong answers. So why this condition is important? So let's consider one case where a is 59 and b is 59, and let's consider c as something like 31. Okay, so what we are saying that total there are p bits set in the C. Now what are the number of bits set in X? The number of bits set in X is nothing but p plus d by 2, if we consider d as a plus b minus p. So this p plus d by 2 should be less than equals to 60, right? Because we can only set 60 bits in either X or Y. So this p plus d by 2 should be less than equals to 60. So this condition is important. If d plus p is greater than 60, our answer will be minus 1. So there are 4 cases where answer is minus 1, and in the else case I am constructing the value of X and Y. This is a constructive algorithm problem, so there could be multiple ways to approach this problem, and could be multiple ways to solve this as well. For X and Y's values will be different in each of the implementation. In my implementation, if we change this, like if we take the first b minus d bits in in Y, and the next a minus d bits in X, then the answer will be different. So I hope you get it. You can have some different way to solve this also. I have just explained my way to solve this. I will also provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. Also, if you have any doubt in any part of the explanation, you can always write in the comment section. I will try to reply each and every comment. Thank you.